Hi everybody, in this video, I'll be talking about isotopes. In a previous video, I talked about atoms, atomic number, atomic mass, and how there could be different isotopes available due to the change in the mass, but they have the same atomic number. So when an atom has the same atomic number, that means it is in the same position. But they could have different masses because number of neutrons within the nucleus is different. So we are going to be studying about isotopes, mainly about calculations. When it comes to isotopes, all you have to know is if you have two numbers here. So let me say, take the smallest isotope. If I take proton, which has the top number is the mass, bottom number is the atomic number. I'm just refreshing your memory on that. This is atomic mass. So atomic mass is the combination of neutrons per protons. Atomic number is just the protons. So if it is 1, that means 1 here protons, and this figure also top here is 1. That means that it doesn't have any neutrons. It only has protons. Another isotope of hydrogen is 1H2, which is called deuterium. So here you will have 1 neutron, 1 proton. Then when it comes to tritium, which is the third isotope of hydrogen, first one is protium, deuterium, tritium. So it has 2 neutrons and 1 proton. And here that is the proton. Because if you change the number of protons, then you change the element, you change the position within the periodic table. So the top number always says the combination of neutrons and protons together. That's why you call it mass, because the contribution to the mass comes from the mass of neutrons and mass of protons. For the atomic number, it is the proton. Because it's an atom, it is neutral, so it will have the same number of electrons. But if it is an ion, then the number of electrons would change depending on if it's an anion, more electrons, if it's a cation, less electrons. We have done that video already. Now here, when you talk about these isotopes, there's something called abundance in nature. That what it means is, if you just take a sample, in that abundance or relative abundance, to be clear, relative, always it's not absolute values, we are going for relative. Now, if you take a sample of hydrogen, it should have 1H1, 1H2, and 1H3, all 3 types. The relative abundance tells us what percentage of each one exists. What percentage is here? Hydrogen, that deuterium, and tritium. So we are these percentages, so total should come to 100. Okay, that percentage is known as relative abundance because related to other 2 or whatever other isotopes. So there's a formula to calculate that one. It is just, if you're good in mathematics, you know that you could calculate it in a normal way. So when they will do an example for you to understand how to calculate. And then I will also tell you, if you're not given the values, but you're just given 2 or 3 types of isotopes of the same element, how to tell which one should be in abundance. So those are the 2 we are going to be doing in this video. So for an example, we say you have a sample of cesium. Okay. And in this sample, now if you go to cesium in your periodic table, let me get the periodic table here. So cesium is in the first group. If you go down, it's just above francium. So cesium is here. Okay, and the position is the 55th element. That means 55 protons are there. Then if you know the mass, which is I'm looking at about 133, then the difference would give you the difference between 133 and 55. You would get the number of neutrons. Okay, that's not what I'm trying to tell you here. A sample of cesium cesium has 3 types of isotopes. So the first one, if you are given this question, so if somebody tells you there are 75% atoms of cesium-133 and 20% of them in the sample would be cesium-132 and 5%, because then it comes to 100%, would be 134. So they have given the abundance. This is the abundance is given. Then looking at it, you can say 133 cesium is the most abundant element or the isotope of cesium available in nature if you take a sample. Now, in order to calculate the cesium average atomic mass, what you do is you take the mass of this 75%, take the mass of this 20%, take the mass of 134, and then you get the value. Okay, that would be the average. Cesium exists in 3 forms, but the average atomic mass has to be the contribution from all 3. 133, 75% contribution, 132, 20%, 134, 5%. So the calculation is done in this way. So 75% means 7500 times 133 plus 20% is 2100 times 132 plus 500 times 134. So the total of that would come to 132.85. That is the number you would see in the periodic table below. So I should make it 85. That's the number. Okay, so when you are calculating, we round it up or down depending on the number, but this is the actual average atomic mass. All right, so these sort of calculations you will get for the exam. But suppose this is a derivation of this calculation. Suppose they didn't give you this. Let us say you didn't have this. They say we have 133, 132, and 134, but they have allowed you to use the periodic table, and they're asking, so you don't know these percentages, because looking at it, 75%, you know, this is cesium-133 is the most abundant. But if you're not given for the test, if you're just given these 3 types and ask which one is in abundant, you look at the periodic table and look at this number. Look at that number. So if the number is 13285, we'll say, so from the periodic table you can see that number. Look at the masses of each one and see which one is the closest to this one given in the periodic table. Okay, if you have a periodic table, they will give you, otherwise they will give you the average atomic mass is this, which is 132.85, and they ask out of these 3 isotopes, which one is more abundant? So the one that is abundant is the one with the mass closer to 132.85, because you can say 134 is away, 132 is a bit away, 133 there's only a 0.15 difference. 0.15 difference, because if you add 0.15 you get 133. So this is the closest. What you do actually is you get the mass and then take away the actual given average atomic mass, then write down the differences. So you see these differences for both. And then the one that has the shortest difference, which means the given average atomic mass and the mass given here above, which is that should be the one that is contributing the most towards the average atomic mass. What it means is this is the one that is in abundance. Okay. All right. So to clear this one, we'll do a few questions. So suppose you have 80% of iodine 127, 17% of iodine 126, 3% of iodine 128. Okay, so if they ask you to calculate the average percentage, what do you do? 80 divided by 100 times 127. So that will be the contribution by this isotope 12790. Then 17% divided by 100 times 126. That will be the contribution by this 126. Then 3 divided by 100 times 128. That will be the contribution by this 128 ID. And then you just add them together. I have the answer. I have got the answer here. Atomic mass unit 12686. So you can do these things yourself. You must do it. Then you will know that. But suppose these values are not given. Let me cross it out with blue color. So suppose you don't have these things. Okay. Then if they ask which one is, because you don't know it yet, you just see this, the difference between 126.86, which is the average atomic mass. Atomic mass unit is the unit given here. Then difference between 127 and 126.86, 126 and 126.86, 128 and 126.86. You will see that the smallest difference is in 127.I. So that is the one, the most abundant element, isotope. Okay, that's how you calculate. Let me do another one. So we say I have 50% of 197 AU and 50% of 196 AU. That's gold. This one 107 6. Add these two together, 197.5. Now here, what is in abundance? No, both are equal 50%, because if you take this value and the difference between 197 and 197.5, it's 0.5. And 196 and 197.5. Okay, so here there's a misnomer here, because 196 and 197.5, that's a bit of a difference, 1.5. So you can say 197 would be the higher, then you will wonder why these percentages are wrong. So this is a question I picked up from another book. In this case, I would say 197 is the most abundant, but from the given figures, it gives a different value. Okay. So this is an exceptional case, but normally if you're given just the two numbers, you get it to the one that has the shortest difference. Okay. The method is the same. Method doesn't change. Okay. It says the values I have here. Let me do another one. So I say I have 15% of iron 55. And then 85% of iron 56. So if they ask the abundant thing, you get 100 times 55, that value, 85 divided by 100, 6, that value. Got a value here, 55.85. So this is the abundance, which is average atomic mass given as AMU. So that's how you get the values, because you can say this is 80. That going to the previous method, I told you if you are not given these percentages, then 55.85 and 56, the difference is 0.15, and 55 and 55.85, the difference is 0.85. So 0.15. So this is the one in abundance. It matches that 85%, unlike that gold previous one. Okay. There are no trick questions. They are not going to give you like the one I told you, golden, because if they give you the percentages, you see which one is in abundance. Then they're asking only the average atomic mass. Which you do is you get the percentage multiplied by the given mass, plus again the percentage given by that mass. Okay. Now, if they haven't given, then you go to the periodic table. If they don't give you the atomic mass, you look at the value, the larger one out of the two. One is atomic number in the periodic table. So what the top one is atomic number. That doesn't have to be top or bottom. You have to go by that. The largest one is atomic mass. So you go with that, and then you see from the isotopes given which one is closest to this atomic mass. That would be the one in abundance. Okay. All right, everybody. I hope this helps you to understand isotopes, how neutrons make a difference and creates isotopes. And you can find the abundance. If they are given the percentages, you find the average atomic mass. If they haven't given the percentages, by looking at the average atomic mass given on the periodic table, you can see the difference between the isotopes, and the one that has the least difference would be the one that is abundant.